For example number 5, we want to find the zeros of a polynomial function. The rational zero theorem helps us to narrow down the list of possible rational zeros for a polynomial function. Once we have done this, we can use synthetic division repeatedly to determine all of the zeros of a polynomial function. So how do we go about this? Well, given a polynomial function f, we're going to use synthetic division to find its zeros. Step 1, we have to use the rational zero theorem to list all possible rational zeros of the function. Step 2, we're going to use synthetic division to evaluate a given possible zero by synthetically dividing the candidate into the polynomial. If the remainder is 0, then the candidate is a 0. If the remainder is not 0, then you discard the candidate. Step 3, we're going to repeat step 2 using the quotient found with synthetic division. And if possible, then we continue until the quotient is a quadratic. Step 4, we're going to find the zeros of the quadratic function. Two possible methods for solving quadratics are factoring and then using the quadratic formula. So for example number 5, we want to be able to find the zeros of the function 4x cubed minus 3x minus 1. Now starting with the rational zero theorem, it tells us that if p over q is a zero of that function, then p is a factor of -1, which is the constant term, and q is a factor of the leading coefficient, which is 4. So remember that p over q is equal to the factor of the constant term divided by the factor of the leading coefficient. So we're going to find all the factors of -1 and all the factors of 4. Well, the factors of -1 are plus or minus 1, and the factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. And all the possible values for p over q are plus or minus 1, plus or minus 1/2, and plus or minus 1/4. Now these are the possible rational zeros for the function. And then we will use synthetic division to evaluate each possible zero until we find one that gives a remainder of 0. So the best one to start with is you can start with 1. So we're going to start with 1, and then we got to write down our leading coefficients. Now if you notice, there is a missing term here, and that missing term is the x squared. That's why we have a 0 here. So we have 4, 0, -3, and then -1. And then we're going to follow the rules for synthetic division. Bring down the 4. 1 times 4 is 4. 0 plus 4 is 4. 1 times 4 gives you 4. 4 minus 3 gives you 1. 1 times 1 is 1. 1 minus 0 is 0. Now since we get a remainder of 0, then we automatically know that this 1 is a factor, which means that we have x minus 1. So dividing by x minus 1 gives us a remainder of 0. So 1 is a 0 of the function. The polynomial can be written as x minus 1 times 4x squared plus 4x plus 1. Now this is a perfect square trinomial, and since the quadratic is a perfect square, then that means that this is the same thing as 2x plus 1 times 2x plus 1, which means 2x plus 1 squared. So we already know that 1 is a 0 of the function. The other 0 will have a multiplicity of 2 because the factor is squared. And to find the other 0, we can set the factor equal to 0. So we're going to take 2x plus 1, set it equal to 0, and then solve for x. When we solve for x, we get -1/2. So the zeros of the function are 1 and -1/2 with a multiplicity of 2. Now if we look at the graph of the function in this figure, notice that at x equals -0.5, the graph bounces off the axis, indicating that there's an even multiplicity for the 0, -0.5. And at x equals 1, the graph crosses the x-axis, indicating the odd multiplicity for the 0, x equals 1.